Alright, this video is just to help you work on this plated algorithm. Remember, the idea is that the curves that constitute the Lusona are moving at these 45-degree angles. And you're always going a complete 180 at the corners. On the edges, it's a 90 degrees. So let's do a couple of these. So it doesn't matter where I start, but I'll start here. When I come to the edge, I turn 90 degrees. And I keep on going. Come to the edge, I turn 90 degrees, and I keep on going. Come to the edge, turn 90 degrees, come to the edge. And in this case, I'm back to where I started. But I have dots that have not been enclosed. All the dots need to be enclosed. And so I'll keep on going. I'll use a different color. If I do a diagonal down here, when I come to the corner, it's a 180. And it's back up. And then I need another one. So I'll go up and then 180. This is a 3 by 3 grid, and it had 3 curves. Now, some people benefit from thinking about this as if it's a ball bouncing around a room or a pool ball bouncing around the edge of a pool table. And that's fine too. So imagine that you've shot a pool ball and it hits the side of the table. Well, it bounces, right? Bounce, bounce, and then kind of missing the pocket, hitting the edges here. Bounce, bounce. So into corners it bounces right out of. On edges it bounces 90, and it keeps bouncing around the pool table. This one is 3 by 4, and it's monolinear. So 3 rows, 4 columns. You might want to go ahead and set up this. This one is 3 by 5. Maybe set this one up and try doing it yourself. You could pause the video and see if it works out. So if you want to, go ahead and pause. Now I'm going to do it. So and it doesn't matter. I usually go down, but you could also go up, because the algorithm tells you what to do. We're not going through the dots, we're going around the dots. And when we come to the side, we turn 90 degrees. See, these dots are guiding us into the corner. Sometimes people will lose track of where they are, and they might do something like this, and it kind of messes everything up. You may want to do this in pencil at first. But these dots are themselves on 45s, and so if you think about it, you're going in between these two corridors of dots. You're going down the middle of them into a corner, side wall. Here's a corner, side wall, side wall, side wall, into a corner, side wall, corner, side wall, side wall. And so this was monolinear. Right? What about this one? Can you tell the dimensions of this? Number by number, what is this thing going to be? 2 rows by 4 columns, 2 by 4. You might want to pause the video and try doing it yourself. Alright, so now we're back. If I go down like this, notice that I end up back to where I started, but I have not enclosed all the dots. So I'll do another one. Again, you can start anywhere. You could start over here. If you're having trouble doing this, well, that's normal. This is a skill that takes practice. We want to be able to do the skill so that we can then investigate some of the properties. So this was 2 curves. Now remember, your classmates haven't done this either, so you're all in the same boat. It's just going to take some practice. What about this? This is what by what? 2 by 3. And let's see. There we go. I should say along the way, This is sometimes depicted as a tortoise. This is sometimes depicted as an antelope. This is sometimes the footprint of an antelope, sometimes represent friendship, and a couple other usages. Alright, over this one. Actually, that's the same size. Let's make it a little bit bigger. Say 2 by 5. So this one was mono. What about this? 2 by 5. Maybe try it out. Let me pause the video. Okay. Monolinear. Couple more. These ones are a bit more tricky because they're not rectangular, but we can still use the same algorithm. It sometimes helps to put little imaginary walls here, going back and thinking about a pool table moving along, a pool ball moving along a pool table. Imagine you had a weirdly shaped pool table. Actually, it'd probably be pretty fun. So you have some weird combination of tables that have been hooked together. Imagine how the ball would travel, right? So depending on how much space is here, right, you'd go right down the middle, bounce through the corners, right back up to the top, bounce, and there's one complete bit. And then we have this one, right? And also this one, that hasn't changed. And then down here, same thing. And you can see this is sort of two of the tortoises put together. So this has got it's got 1, 2, 3 components, 4, 5. So this has got 5 curves. Right. All right, so we took two figures that were not monolinear and we glued them together. Let's look at this one. What can we do here? Well, if I start, I'm into a corner, hit a wall, a corner, a corner, a corner, a corner, and then right back up to the top. So this one is monolinear. And think about it, the 2 by 3 was monolinear, and this is 2 by 3s that have been glued together. So your goal for the next class is just to be able to do these doodles, to fill in these grids so that you can do experiments. That's your goal.